Okay, good morning. Today we'll be looking at indices, how to simplify some problems in indices. Indices, either call it index 6 or call it exponents or powers. Now you may have a problem in index 6, you're asked to simplify. Let's do this as an example. Like somebody asked a question like this sometime and says simplify a raised to power 1 over 2 plus a raised to power 2 over 3 all over a minus a raised to power minus 1. Now if you look at this, you see that this is an indicial problem. Now if the student was asked to simplify this but doesn't know how to go about this. Now, for you to be able to do this, let's look at the solution to this. This is very simple if you can follow the process. Now, if you look at this, the first thing you need to do is to discover that this is an exponential or indicial problem. Now, you can only use the exponent rules. You can only use the exponent rules to solve this, which you're supposed to be familiar by now, the exponent rules. Now using the exponent rules, if you have this, you're going to have a raised to power 1 all over 2 plus a raised to power 2 over 3 all over a minus now you will convert this a raised to power minus 1, that becomes 1 over a. Now that we have this, you can either look for the LCM. You can work with the denominator first and find the LCM, or you can go further by writing all the numerators above the common denominator. So the next thing we can say, write all numerators. Write all numerators above. Write all numerators above the common denominator. Above the common denominator. That is a raised to power 1 all over 2 plus a raised to power 2 over 3. Then we do that will become over a square minus 1 all over a. So this is what we get when we write all the numerators above the common denominators. Now you can equally say you're looking at the LCM of this. If this is like a whole number over invisible 1. Now if you take the LCM of the two, you're gonna have a, which is this. Now if you do it, a divide by 1, this, we say this is over 1. So if you do this by 1, we're gonna give you a, and a times a, we're gonna give you a square, which we have here. Or equally with the same thing, a divided by this a, that will be 1. Now 1 times 1 will give us 1. That is how we got this one. So that is equally another method if we want to use the LCM method. Now when we get this, what's the next thing we do? We simplify. See, we simplify the fraction. We simplify the fraction. Now simplifying this fraction have to give us this. Now we have a raised to power 1 all over 2 plus a raised to power 2 over 3. Now all into what? A all over a square minus 1. Now if you look at this, you know what I did there. From the exponent rule, we have a fraction here. So it's like taking this is same thing. This is something to say a raised to power 1 over 2 plus a raised to power 2 over 3 divided by a square minus 1 all over a, whereby if you change your division 2 times, the one down will go up and the one up will come down. So that is how we did it to get this. So now we have this. The next thing we're gonna do now, is to multiply. Say multiply the parentheses. Next thing is to multiply parentheses. Yeah, parentheses by a, you multiply the parentheses by a, that is to say a raised to power 3 all over 2 plus a raised to power 5 over 3 all over a square minus 1. So you can see if we multiply the parentheses by a, that we're going to have this. How did we do that? If you look at this, this is a multiplying this. If you look at a, this a raised to power 1, there's an invisible power of 1 in this a. So if this a raised to power 1 multiply this a raised to power 1 over 2, we're going to have a raised to power 3 over 2. Then plus, if this a multiply this a raised to power 2 over 3, you're going to have a raised to power 5 over 3. Then over a square minus 1, which we have there already. Now, the next thing we do is to transform the expression. Transform the expression. Now, how do we transform the expression? You know that by now we're supposed to know how to transform something like this when we have this and something like this. Now, this will give us square roots of that will give us square roots of a or raised to power 3. You can see that they have plus, and this will give us cube roots of a or raised to the power 5. Then we still have our we still have over a square minus 1. Now we still have that there. Now we're looking at, let's say, after that we're gonna have we're still looking at the transformation. Remember, where we have this, you have root of a all raised to the power 3 plus cube root of a raised to the power 5 over a square minus 1. Now we're trying to transform this. Now you can see that this root of a all raised to the power 3, which you have there, is same thing to say, the same thing to write as root of a times root of a times root of a. So you can see it's the same thing, then plus, then the same thing goes to our cube root of a of 5. Understand? Now if you have the cube root of a into 5 places, that will still give us cube root of a times cube root of a times cube root of a times cube root of a. Now you can see that, you can see cube root, let's say we put it here because of space, we don't break it, a times this. So you can see that is up to 5. 1, 2, 3, 4, 5. So multiplying to 5 places, then we still have over a square minus 1. Now this will give us you see this root of a times root of a, that will give us a. I think so, because a times a go a square, and root of a square give us a. So we have a root a. You can see that. So now that we have a root a, so we have plus, okay. Then if you look at this, remember, sorry, this is cube roots. This is cube root, please don't forget. This is cube root. Cube root of a, because space, cube root of a. Now if you look at this, you have a root a plus. Now you look at this, if you multiply 3 this is going to give you cube root of a times cube root of a times cube root of a will give us cube root of a cube, and cube root of a cube is going to give us a, and we still have this. So we have a cube root of what? A square. So I believe I believe you are with me there. So when you multiply this, you're going to have a cube root of what? A square. When you have that, they have over what you still have there, a square minus 1. Yeah, that's minus 1. So if you look at this, you get a root of a plus a cube root of a square all over this. So this is simply by simplifying, you can say simplifying the roots. So already here you have the roots. So you can equally say here, you say the next thing to do here is what? simplify the roots. Simplify the roots. So when you simplify the roots here, you're going to have this, which implies that a root a plus a cube root of a square all over a square minus 1. That is the final answer for this simplification. Thank you for listening.